So today we are starting on differentiation, and the first example I'd like to show you is differentiating from first principles. There's an example here, 8x squared plus 1. The first step I suggest you take is to work out f of x plus h. So sub in x plus h to replace the x. So 8x squared plus 1 becomes 8 by x plus h squared plus 1. And then we expand and simplify as much as we can. So it's a perfect square, which we know how to expand a perfect square. X squared plus 2hx plus h squared. Keep expanding. And that's as far as we can take it. So to put it all into the formula now for first principles, we want to find f dash x, and it's equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. That's the formula that you'll always use for first principles. And now we sub into it whatever we have. So it's the limit as h approaches 0. Now f of x plus h is this. Minus fx. So minus 8x squared plus 1 over h. Now we'll go over the page. So we have the limit as h approaches 0 of 8x squared plus 16hx plus 8h squared minus 1. Then we had the negative out the front of the bracket. So, oh sorry, that was a plus. So minus 8x squared minus the 1. I've removed the bracket that had the negative out the front, so the 1 becomes negative. Then we simplify that. The 8x squared will cancel with the minus 8x squared, and the 1 will cancel with the minus 1. So on top we have 16hx plus 8h squared. Now there's a common factor of h on top, which we can factor ours out. Notice that I'm not interested in taking out the common factor of 8, just the h, because that's what will cancel. So it's the limit as h approaches 0 of 16x plus 8h. Now I can't simplify that anymore, so I'm ready to sub in h equals 0 into this. So it equals 16x plus 8 times 0, 16x. So we've differentiated that from first principles.